Of Proflan YouTube channel. In this particular video, I'm just giving the final tip for IGCSE 0625 Theory Paper 4. So we've been making videos on various topics that you really need to prepare for this exam, and in this particular video I want to take you through the most important formulas that you need for tomorrow's exam. So if you've not mastered these formulas, you better understand how to use them so that when you be given questions to do, you will be able to do that. And we're going to focus on the topics that you need to understand for the entire syllabus of IGCSE Physics. So, and towards the end, I'll also give you the main tips and the main formulas also you require as far as space physics concerned. So the first part is kinematics and motion. You need to understand how to work out velocity displacement over time, and distance is speed is a scalar quantity while velocity is a vector quantity. That's why you can be able to see that. Then we need also to understand the formula for acceleration, and this formula that we have here is very key because it's if we have this formula, we can be able to rearrange it in order to have this. And where is this coming from? We are having acceleration is equals to v minus u over t. So you see, if you multiply t both sides and then you make v the subject, the formula, we are going to get this equation. So in this regard, I want you to ensure that you remember that acceleration is a vector quantity and it's calculated by this particular formula that we have at this given point. We also need to understand weight is calculated by mass times gravity. That's also another key formula you need to understand. And for you to work out, maybe you are told a mass is 2 kg and you are supposed to calculate the weight. Then you need to know what is the gravitational field strength, which value of g is given. You check in your paper, there will be g given, g is provided, so you can be able to use it. Now for instance, if you're having the mass in kilograms, you go ahead and substitute. You say 2 times, if g is 10, you are going to say that is 20 newtons as the mass for as the weight for this. And you need also to understand that this formula weight is equals to mg can be rearranged, and mass is going to be equals to weight divided by gravity. So formulas can be rearranged so that you can be able to work out a known quantity. You need also to understand the formula for density. Density is equals to mass over volume. I believe you may be asked a question on how to use this formula, and if you are given mass and you are supposed to work out if you are given density and the volume, then it means mass is equals to density times volume. So every time you are going to do a question, the most important thing you need to understand is what are you given and what are you finding. Another formula that's going to be very prominent in tomorrow's exam is the formula for mass is force is equals to mass times acceleration. This is Newton's second law. So if you are told that maybe there is a force acting on an object, there is a resultant force. Then if you are working out maybe the acceleration, and if the force maybe is 3 newtons, resultant force is equals to the mass. If the mass is 4 kg, yeah, what is the acceleration in this case? You can be able to say 3 is equal to 4 times acceleration. If you are finding acceleration of this object, you'll say 4 divided by 4, and acceleration is 0.75 meter per second square. So basically this formula for Newton's second law of motion, very important for IGCSE exam. A moment of force is is force times perpendicular distance. And what you need to remember at this given point is that if maybe you are given a system and this is the pivot at this given point, if there is a force acting at this point, let's say 2 newtons, and we have a distance, there is another force acting here, x, then for us to work out that, we need to know the perpendicular distance from the pivot to where the force is acting. So let's say this is 0.5. And if you are having a distance here which is equals to 2, you can be able to say clockwise moment is equals to anti-clockwise moment, and this is going to be, clockwise is going to be this direction, anti-clockwise is going to be this direction. So if you are working out the moment, in that case you are going to say clockwise moment. I'm just showing you how you can be able to use this formula. Clockwise moment is equals to anti-clockwise moment. Anti-clockwise moments are here, so we can say clockwise moment is x times 0.5 is equals to anti-clockwise moment, which is 2 times 2, and that is going to be the force x is going to be 4 over 0.5, and that's going to be 0.8. So you need to understand how to use these formulas. For me, I'm just mentioning the key words that you need to remember. Moment is equals to that, and also if they ask you to state the principal moment, we say clockwise moment equals to anti-clockwise moment. Another formula you need to understand is the formula of Hooke's law, and you can be able to use to work out the spring constant. So for instance, if they are going to give you force extension, and if it's a straight line, it means this material obeys Hooke's law. And if they want you to find the spring constant, you need to come on the graph so that you can be able to do what? You can be able to identify. For instance, if you check the straight section of the graph, you can pick a point and read the value here. Let's say it's 0.4, and the units here extension was given in meters. Let me just use that in meters. And if you read also on this end here, you find that the value is 10 newtons. The force is in newtons. Then you can be able to say therefore 10 newtons from force is equals to what? Ke. 10 newtons is equals to spring constant K times the extension, which is 0.4. Then from here we can divide by 0.4, and we can divide by 0.4, and our answer here is going to be K is equals to 0.4 divided by 10 divided by 0.4. So this is going to give us 0.4 is going to give us 25. It's going to give us 25 Newton per meter. So this is the spring constant of this. So another formula that is important is the formula for momentum. Momentum is equals to mass times velocity, and remember momentum is a vector quantity. Once you understand, also remember the law of conservation of momentum, which states momentum before total momentum before collision is equals to total momentum after collision. So this is going to enable you to work out different problems, but most importantly, remember momentum is mass times velocity, and also impulse is equals to force times time. Remember that impulse is force times time, and the way to work out impulse is also considered to be the change in momentum. If you have an issue on how to work out question with momentum and impulse, I've done a video below here, so that in this channel, you check in the description, you can be able to watch that. The law of conservation of momentum is total momentum before collision is equals to total momentum after collision. For work, energy, and power, you need to understand that work done is force times distance, and distance should be in meters, and the force must be in newtons. and gravitational potential energy is mgh. So meaning that if this is the ground and then we happen to have a tall building, yeah, a tall building. So if there is a boy standing here with a stone, it means this stone is at a given height, h. So if the stone has a given mass m, then the gravitational potential energy it has at that point, it will be the mass in kilograms times gravity times the height. As the stone falls through that height, the potential energy will be decreasing, kinetic energy will be increasing. So at this point down here, it will be having maximum kinetic energy and zero potential energy. So that's why sometimes you can see we can be given a question where you are asked to find the velocity at which it hits the ground. You are going to say mgh is equals to kinetic energy, and you need to remember that kinetic energy is equals to mass times velocity squared divide by 2. Power is energy, rate of doing work. So it can be also rate at which energy is transferred, so which means that you need to remember that energy is equals to work done over time. Remember that, and also remember the concept of efficiency. Efficiency is useful energy output over total energy input times 100%. Also it can be used power output over total power input, and that is going to be that. Pressure in solids, we are going to use pressure is force over area, and then we are also going to talk of pressure in liquids. So for instance, if we are talking a liquid in a swimming pool, if we are having maybe a material, a substance in water, then if we want to work out the pressure acting on this object, is going to be what? We are going to check how deep is it, the height, yes, and what's the density of the liquid. So pressure in liquid is going to be the density of the liquid times gravity times height. But also if you are told there is atmospheric pressure acting on the surface of the liquid, so the total pressure down here is going to be the pressure due to the liquid column plus the atmospheric pressure. So you need also to remember the formula for pressure, Boyle's law. P1 pressure 1 times volume 1 is equals to pressure 2 times volume 2. Yeah, so another formula that is very important is the formula for specific heat capacity, which means that if we are working out the amount of thermal energy absorbed by a liquid or a substance, we check the mass of the substance given in kilograms times specific capacity times the temperature change. Remember that. But heat capacity at this point, you will not be really working on that. And something I need to mention, if you are asked to define specific heat capacity, what do you need to say? For specific capacity, you are going to say is the amount of thermal energy required to change the temperature of a substance by 1 kg, by 1 degree Celsius. Specific capacity is the amount of thermal energy required to change the temperature of 1 kg of a substance by 1 degree Celsius. So another set of formulas we shall talk about is the formula for the wave equation. This is the wave equation. Wave equation is equals to velocity of a wave is equal to frequency times wavelength. And also you need to remember that frequency is 1 over time period, or time period, periodic time is 1 over f. So for waves, this is the formula that you need to understand. This one, and this one is probably the formulas that you really need as far as waves is concerned. When we are talking about refractive index of a material is sin I over sin R. So for instance, if we are talking of a light that is moving from air into glass. So for instance, this is air and this is glass. So if you are finding the refractive index, we need, this is going to be the normal. So this angle between the normal and the incident ray is angle of incidence. Then when this material enters at the boundary, the material is going to slow down, because if the ray of light is moving from air into glass, glass is more dense, so it will bend towards the normal like that. It will slow down and bend towards the normal. So the angle that we have down here is the angle of refraction. So we can be able to say now at this given point that the refractive index, suppose this is 30 degrees and this is 17 degrees. If you are working out the refractive index, you are going to say sine 30 over sine 17. And if you need, you put that in your calculator, you are going to say sine 30 over sine 17. You get your answer equivalent to 1.7, and the refractive index does not have any units. Another formula that is important in this area is also the relationship between the refractive index and the critical angle. So you are going to be asked maybe to work out the refractive index when you are given the critical angle. For instance, you are going to say, if you are given the critical angle of a material, critical angle of a material is 42 degrees, find the refractive index. You are going to use this formula. You are going to say refractive index is 1 over sine of the critical angle, which is going to be 1 over sine of what? Sine 42. So if I put that 1 over sine 42 in my calculator like this, and then I click the equal sign, you can see the value that we are having there, and the value is 1.5. This is the refractive index for this particular material. Another case, if you are given now, you are given the refractive index. For instance, you have gotten the refractive index here. We have gotten the refractive index, and then you are supposed to find the critical angle. What do? You are going to use the formula sine of critical angle is equals to 1 over the refractive index. So we shall say sine of C is equals to 1 over 1.7. Then C is going to be sine inverse of 1 over 1.7, and then you put that in your calculator. Let me show you how you shall put it. You shall say shift sine, so that you have that shape sine inverse, and you say 1 over 1.7, then you put it like that in your calculator, and then equal sign, that is going to be what? 36.0. So this is going to be 36 degrees. So that is how you are going to use those formulas. Also, you need to remember for electricity, because electricity is another area that you'll be seeing in that paper. We are going to remember that current is equal to charge over time. All charge is equal to IT. This is the way it's easier to remember it. Charge is equals to IT, but I must be in amperes and time must be in second. So if you are given time or you are given time in minutes, remember to do the conversion so that you have it in seconds and don't make any mistake. Also remember that V equals to work done over charge. Remember also the most important formula here is V, this is Ohm's law. Ohm's law. Voltage is equals to IR, and electrical power is this, and also power is current times voltage. And don't forget, electrical energy is equals to current times voltage times time, IVT, or energy is given by power times time, power times time. So those formulas should be very, very fresh in your mind as you are going to see it for tomorrow's paper. And I need also to finish by mentioning that if you are going to sit for tomorrow exam, there is this formula that is very, very important. If you are given a circuit, a potential divider like this, and you are supposed to work out the voltage. Now, for instance, let's say this is 12 volts, and then we have a resistor here which is 10 ohms, and down here you have 5 ohms. So if they are asking you the voltage that is tapped out, V out, you are going to say V out is equals to R1 over R1 plus R2 times V in. V in is the input voltage here. So you are going to say V out, you are going to consider the resistor where the voltage is tapped from, where the voltage is removed from. So if you're working out V out, the resistor you shall have at the top here is that resistor, that given point where the voltage is removed. So we are going to say V out is going to be equals to R1, where the resistor, the V out is being tapped is 5 over the sum of the two resistors, which is going to be 5 plus 10 times the total potential difference, which is going to be 12. So this is going to be 5 over 15 times 12, and this is going to translate to what? Let's see. This is going to be 5 goes to 15 once, here goes 3 times, and this once, then 4. So we shall have 4 volts as the V out. Our V out is that. If resistors are in series like this in a circuit, and you are supposed to work out the total resistance, this is 4 and 2 ohms. Yeah, if you are working out the total resistance, it will be R total is going to be equals to what? 4 plus 2, which is going to be 6. Now, if maybe there was a potential difference of 30 volts, the current that is going to flow in this circuit here is going to be V is equals to IR. So I, which means that I is equal to V over R. So V over R. So meaning the current that is going to flow in this circuit is going to be 30 over 6, and that is going to be 5 amperes. So that is how you use these resistors formula, and if they are in parallel, you are going to say 1 over R total is equals to 1 over R1, 1 over R2, and that. Now let me give you just a shortcut. So if you are going to have a circuit whereby you have 2 resistors which are in parallel like that, we have an ammeter here, and let's say this is 10 volts and this is 3 ohms. Let me use just a number that's divisible and easy to write. That is 2 ohms, and we have 4 ohms here. So if you're working out the current in this ammeter, we need to find the total resistance, and total resistance, I'm going to give you a shortcut. You are going to, when they are in parallel, you are going to say 1 over 2 plus 1 over 4, then you raise -1. You put in your calculator direct instead of just doing this. Just put 1 over 2 plus 1 over 4 when they are in parallel. So 1 over 2 plus 1 over 4, open the bracket, raise to -1. And then our answer is going to be what? 1.3 ohms. That's the resistance in this circuit. So if we want to know the current, we say current is equals to V over I, and that is going to be 10 over 1.3. And if you put in your calculator, you are going to get your answers around 7.5. Yeah. So for transformers, the formula that we require is number of turns in the primary coil over number of turns in the secondary coil is voltage in the primary coil or voltage in the secondary coil. So for instance, if this is a transformer, I'm just giving this as an example. If you have not watched the question, the video on electricity and transformer, electromagnetic induction, all those videos are in the description here so that you can be able to go and watch. So this, we have those turns there, and here we have a set of turns. So this is turns in the primary coil, primary, and this is what? Secondary. So in order to also, I explained, you check in the description, you watch that video, I explained how to do these calculations, I gave questions, and also explained how a transformer work. You need also to remember in space physics, you need to understand that this is Hubble's law. Hubble's law, whereby h naught is Hubble's constant, and v is the speed at which the galaxy is moving away, and d is the distance between the Earth and the galaxy. So if you want to determine how fast or the speed of a galaxy, you need to use this formula that we have given here, and you shall say that speed of a galaxy is going to be Hubble's constant times the distance that galaxy is from Earth. So that question probably will be tested, so you need to understand how this works. And also, if there is an object that is going moving around its orbit, for instance, we have a planet moving around the sun like this one, you need to understand the speed at which, this is the orbital speed at which it's going around is going to be 2 pi r over the time period. Time period is the time it orbits around the sun. And also you need to understand different aspects, the nature of different orbits. And we have orbit of a planet. These are the orbit that are around the sun, where planets follow that particular path. We have orbit of the moon and satellites, they orbit around a planet. And we have the orbit of a comet. A comet, it orbits the sun, but its orbit is quite elliptical, quite elongated. But the orbit of the moon is circular around a planet. So basically you need to understand those aspects as far as the exam of tomorrow is concerned. Another question that you may be asked is the age of the universe. And the age of the universe is obtained by this formula. Age is equals to 1 over Hubble's constant. 1 over Hubble's constant. And Hubble's constant is approximately 1.0. Hubble's constant is approximately 2.2 times 10 to the power negative 18 per second. Per second, we need to identify that. Per second, so which means that if you take that value and you say 1 over 2.2 times 10 to the power negative 18, you are going to get the age of the universe. So you need to, and also to understand, if they ask you in years, you need to work it. You need to work it out. Another thing I need to mention is that you need to understand what 1 light year mean. One light year mean the distance traveled by light in 1 year, right? The distance traveled by light in 1 year. So basically you can be able to be asked a question on that. This marks the end of the final tip from me on IGCSE Physics 0625 paper 4 of 2025 Major. I really wish you all the best, you guys. May you pass this coming exam. And if you have not, you are having issues, you have not watched my ultimate tutorial on and predictions for this exam, kindly check in the description so that you can be able to watch those videos. Guys, if you have not subscribed to Proflan YouTube channel, take this time so that you can be able to subscribe, and also you can be able to join my Patreon page so that you can be able to go and access this formula sheet that I've really talked about. Yeah, so I really wish you the best of luck. Tomorrow when you are going for that exam, make sure you have your calculator, you have your pair of compass, you have your pencil sharpened, and ensure you have your protractor, so that anytime maybe they are telling you to measure angles, you can be able to measure that. Be confident, don't panic. As long as you've understood all these areas that I've mentioned here, you will be able to do this particular exam. Wish you the best. See you tomorrow. Make sure you come back to give me the feedback how the paper was. Good luck.